Hi there, and welcome to this lecture series on data visualization. This is the first of many lectures to come. I want to start out by showing you an example. This is a website called Gapminder. If you aren't familiar with it, there are a lot of different ways to visualize data on their website, but we're going to start out with their basic Explore tool. Notice that you can choose how you want the colors, what you want the colors to represent. Right now it's representing world region. You can have the size dictate another attribute. Right now it's set to population of countries. We're going to leave that. And then you've got two axes that you can work with. Let's say that we're interested in CO2 emissions per person, which happens to be often searched for. And let's do that against something like GDP. So if you just type in a search term, you can see that there are a lot of different options, and I'm talking a lot of different options. But they do a brilliant job of explaining what each of these variables is. So I'm going to shoot for income, which is an adjusted GDP. And what I want you to notice here is that not only now can we see that there's an obvious positive correlation between CO2 emissions and GDP or income, but we can also see that regionally Africa is not producing a lot of CO2 emissions. The Americas are near the top, Europe and Russia near the top, and you can see kind of where the big countries fall in. There's also this great feature where you can hover on a given point, and little dotted lines help you dial in the exact numbers, or at least make it easier to ballpark the values associated with each data point. And we can play this thing out over time. Not a lot of data going on in the 1800s. As we start to acquire data, the plot gets a little bit more interesting. Populations increase. China on the scene, populations increasing. Hopefully right now you're just thinking, this is fascinating. This is an amazing tool, and I hope that you will take some time to play with it. Okay, so let's get into the lecture. The world cannot be understood without numbers, and it can't be understood with numbers alone. Hans Rosling is one of the co-founders of the Gapminder group that we just looked at their website of. Pretty interesting guy, and laying the groundwork for what we're going to talk about this semester. So what is data visualization? The easiest way to think about it is taking a bunch of text and numbers and turning it into a picture. Data in picture form. So we've got a table. Tables aren't bad. They're really good for giving us precise numbers, precise measurements, and storing data in a really logical way. We can record, track, and share specific values. Data visualizations help people understand the significance of data by placing it in a visual context. So picture form, we can ask questions like, can we see monthly or annual totals? Yeah, it is easy in a table. Are domestic or international sales higher? Tough to say without sitting there and memorizing all the numbers and doing a lot of kind of mental gymnastics. Are sales increasing or decreasing? What else can we notice? When we plot these numbers up, it becomes very obvious that domestic sales greatly outweigh international, that the domestic has a cyclicity to it, that international sales had kind of a weird anomaly in August. Extracting exact values is easier from a table, but identifying trends and patterns is much easier from a visualization. Let me introduce you to Alberto Cairo, admittedly my DV crush. He is a brilliant guy and writes just gloriously about data visualization. He says the first and main goal of any graphic or visualization is to be a tool for your eyes and brain to perceive what lies beyond their natural reach. Visualizations are designed to make our lives easier. There's a grammar and a vocabulary to data visualization. It's made of symbols, visual encodings, text, But don't forget reasoning. You have to be able to critically think about your data. But these different elements are as flexible as language. There's a beauty and a musicality to good charts, Alberto Cairo says. Have you ever read a book that makes you stop and reread sentences because they're so beautifully crafted? I mean, visualizations can do that. They can bring beauty and elegance, but mostly they need to be effective, and it takes work. And reading the good ones takes a lot of work. The charts that are rich in content and worthwhile and drawn to inform civil and honest discussions, these demand our time and attention, and it does take a lot of work. Okay, so what is data visualization? Andy Kirk says, the representation and presentation of data that exploits our visual perception abilities in order to amplify cognition. This is a thick kind of definition, but it's basically acknowledging that humans devote half of their brain, evolutionarily, half of our brain is devoted to vision. We have these natural cognitive visual abilities. And the idea is to tap into those and leverage them in order to make thinking and understanding easier. Okay, so in this video, we're going to take a look at some of the forefathers and foremothers who developed some of the first visualizations, and definitely talk about some more data visualization gurus. There are no absolute rules about how to make a good chart, but there definitely are rules, and they aren't arbitrary. There are principles and guidelines and best practices. There's definitely some creativity and art involved in making an effective display of data, but we understand a lot about human vision and perception, and we're going to talk about ways to leverage what we know about human vision in order to make our charts and graphs more effective. So data visualizations obviously come in many forms, from tables, charts, graphs, plots, which all are words, charts, graphs, and plots that can be used interchangeably, maps, flow charts, pictograms, schematics, infographics, right? So let's talk about why this is important. Has anyone heard of Anscoms Quartet? This is a really cool data set that was developed by a guy whose last name was Anscom. 4 different groups, A, B, C, D, and each group has 11 coordinate pair. There's an X and a Y value for each pair. X could represent height and Y could be weight of 4 different groups. Does that make sense? X could be fuel efficiency and Y could be horsepower. But we basically have these 4 groups. But the summary statistics, the mean and standard deviation is the same for all 4. If we were to take the mean of the X's, the mean for all 4 groups, A, B, C, D, is 9 with a standard deviation of 3.317. And the mean for the Y data sets is 7.5 with a standard deviation of 2.03. Understanding the summary statistics about data sets is really important. The min, the max, the range, the mean or median, standard deviation. These things tell us a lot about data sets, including the skew. The linear regression, so these all intercept at the same place and have the exact same R-squared value. So these are 4 very similar data sets. When we plot them up, they look like this. 4 very different stories, similar relationships, positive correlations. 2 of them are linear, B is nonlinear, D just is quite wonky with an enormous outlier. So we learn a lot more about these data sets when we see them plotted up. Frank Anscom said, make both calculations and graphs. Both sorts of outputs should be studied and each will contribute to understanding. And that's really important. This isn't just about making pictures out of data. It's really understanding your data and knowing what you can do with it. Okay, so it doesn't matter when this image was made. 90% of all data in the world was created in the last 2 years. This means that we are still on an exponentially growing curve of data creation. What this leads us to is the fact that a wealth of information creates a poverty of attention. You know what this is like. We have short attention spans because we have so much information coming at us all the time. Herbert Simon was the father of artificial intelligence. He was a Nobel Peace Prize winner for economics, and he was early to identify this problem that overloads of information creates a poverty of attention. All this information consumes our attention, and we need to allocate our attention efficiently among all this data overload in order to not be consumed by it. And that's where data visualizations can come in, really handy. Simplify things for people, help focus their attentions. But this attention that we give to things needs to be given to graphs and plots and charts that are of sufficient quality. Here's a chart, and I want you to take a moment to make a sense of it. We've got year-wise water quality and Tamil Nadu. I'm sorry if I'm hacking that name. We've got quality on the x-axis and count on the y-axis, and we're color coding by year. So we might be able to read this like, well, there was no 2009 in the nitrate or fluoride quality waters, but that doesn't quite make sense. How about when the water got to the iron quality level, we have the most 2009, right? That doesn't quite make sense either. How about in the year iron, in the iron quality, the count of years 2009 through 2011 sums to 1. 1 what? This is crazy. Wait, there's a total of 0.12 counts of year 2012 in the salinity of water quality. Got it. So you can see that this really was done poorly and doesn't make any sense. I've been paraphrasing a bunch of brilliant responses posted online to this unfortunate graph, and we're going to be looking at a lot more gems like this over the course of the semester. So do you see what's actually wrong with this chart? Do you see the error in how it was set up? What would make more sense? Time in years is being treated as a dependent variable, but year is the independent variable and should be on the x-axis. Water quality measurements should be the colors that vary in quantity per year. Pretty simple fix. Hopefully you guys will make some mistakes like this semester so that we can have a good laugh and try and decode them together. All right, so it does come back to data literacy. The ability to take data, to be able to understand it, process it, extract value from it, visualize it, communicate it, that's going to be a hugely important skill in the next decades, according to Google's chief economist back in 2009. He is absolutely right. Beyond visualization is the need for data literacy. You can't make intelligent visualizations without first understanding what kind of data you have. Can it be classified? Is it clean? Is it old? Is it incomplete? This is a rapidly growing field, and the skills of cleaning and visualizing data are becoming more and more important to scientists as our ability to collect and process and analyze data continues to increase. Edward Tufte, another data visualization guru, says good content reasoners and presenters are rare, but I would argue that scientists and designers are not. And I think that's very true. In order to do this well, you have to wear a lot of different hats. And we're going to get you comfortable wearing a whole bunch of them this semester.